Hey guys, welcome back to my channel. I am Prashant and in this video we are going to solve the problem number 11 in this series, which is shorted matrix search. This problem is often called the staircase searching problem. Now let's jump to the problem statement. Here you are given an n cross n matrix where each row and each column is sorted in increasing order. Also, given an integer x, your task is to find the position of x in the matrix. Basically, we have given a 2D matrix, 2D array that is n cross n, and in which each row and each column is sorted. Okay, let's see in the example. If we see in the example, in this each row is sorted. If we see carefully, all the leftmost elements is the minimum element of all the elements that is present on that particular row, this row or this row. And not only that, all the columns as well. Okay, if you carefully see, all the columns is also sorted. Okay, so the topmost element have the minimum element of all the elements on that particular row. Okay, now if the element exists, print its position as row column. We have to print the row and column if the searching element, that is the integer x, okay, is present on that array. If it does not exist, print element not found. Now a lot of candidate thinks that we can perform a linear search across the 2D array, okay, by visiting all the elements at least one time and comparing the element to the searching element. And if we found, then we will print the particular row and column. And if we will not able to find, then we will print the element not found. But the catch is the algorithm should run in O of n time complexity. So if we try to traverse all the elements, then the time complexity would be n cross n. Okay, but we have to solve this problem in such a way that we will have only O of n time complexity, right? So only one statement make this problem a little complex from the easiest one. Okay, now its output will be the found at 1 0. Okay, the 29 is present on the row of index 1, that is this row, and the 0th column, that is the first column. Now the explanation is very simple. In this example, the value 29 is located at row index 1, okay, row index 1, and column index 0, okay. Hence found at 1 0 is the output. So I recommend, let's try to think first by yourself and try to solve the problem at least one time, then proceed to the video. Okay, if you are able to solve this problem, then you have really nice problem solving approach. Now jump to the approach. Now at the first, the input is given, that is n cross n. Then all the elements of the 2D array, that is 4 cross 4, the 16 elements. Then the searching element at last. Then output should be found at 1, 0. Now the approach we are going to see is also known as the staircase search technique. And why this is called this, shortly you will get to know. Okay, now let's take the same input here. Now let's open the pen. So our approach is like, at the first we have to start iterating from a particular point or an element from where we can go both side means we can go to the maximum as well as the minimum element. So in this particular array or in each array which follows the condition, the sorting condition from the row and column, we can see there are 2 points, okay, the diagonal points. The first one is this and the second one is this, okay, this element and this element. In both the elements we can see there is an opposite behavior in all the directions. Okay, if we are trying to move to the left, okay, left, then we see, so all the element to the left of the current element is decreasing, okay, 40 then 30, because the row is sorted. If the row is sorted, then the rightmost element is the maximum element. It means all the leftmost element of that particular row is the smallest than the right one. Simple. It means if we go to the left, we will decrease the value. Okay, means if we want a minimum value than the current value, we go to the left for minimum value. Okay, left for minimum value. Okay, now if we go downward, okay, then because the column is also sorted, okay, so the topmost element is the smallest element of that particular column. So if we go downward, then the values are in increasing order. So if we go downward, we will get a maximum number. Means if we require a maximum number, we will go to the downward. And if we require a minimum number than the current number, then we will go to the left. And all the things in the vice versa have. If we go to the right side, the value is increasing, and if we go to the upside, the value is decreasing. So for this video, I am taking this element, okay, not this element. We can use this element also, but we cannot do this element. Okay, why not? Or this element, why not? Let's suppose our current value is 10, okay, and we require 29. 29 is greater than 10, okay, and on the both sides, if we go to the right or if we go to the bottom, both sides we will get a greater number. So it will make a confusion that which side should we go. Okay, so in this there is a confusion. So in this situation, this creates an ambiguity or confusion that the 10 is not able to decide in which direction the iteration should move. Okay, so there in the same here also, if we want a lower value, then upper value is also lower and the left value is also lower. So we cannot take 10 or 50. Okay, so let's at first erase this. Okay, now let's see what we will do during the iteration. Okay, now currently we know that if we go down, we will have a maximum value, and if we go left, we will have a minimum value. Okay, now so at the starting point we are here. Okay, let's write the indexes. Okay, 0, 1, 2, and let's say 3. 0, 1, 2, and 3. Okay, these are the indexes, and at first we are starting from the 40. Okay, currently we are 40. Now the first thing that we will do is comparing the current element to the required element, that is the key or search element. Okay, so at first we will compare equality. If the both values are equal, then we will not do anything, we will just return with the row, value, and column. Okay, these are the statements, these are not codes. Now if it is not equal, okay, like in our condition 40 is not equal to 29, so what we will do, we will simply compare is the current value 40 is greater or smaller than required value. Okay, so if it is greater, okay, current value, that is the current value is greater than key. Okay, current value is greater than key, or we can write like this: if current value C is greater than the key, it is for greater. Okay, it is for greater. If the current value 40 is greater than 29, that is true. So what do you think, which side we should have to move? Now if current value is greater than the key value, searching key value, it means all the elements after the current value in that column, particular column, okay, after the current value, that is 45, 48, and 50, must have greater value than 29, because if the smallest element of that particular column is greater than the 29, then all the other elements that is sorted, okay, will also have a maximum value than the 29, because it is greater than the 40 and 40 is greater than 29. It means all the elements after the 40 will be greater than 29, because the current number is greater, okay, and we need the smaller element, so we will not iterate to its column values. Okay, there is no any required or need to iterate these values, because these values will must have the greater element than the key element because of this. Okay, so we will simply avoid it. Now if we have the greater value, so to find the minimum value, okay, to find the minimum value then the current value, what direction should we choose, down or left? So we will go to the left, so we will go to the 30. So after going in 30, after we reaching the 30, again we compare the equality. Is 30 equal to 29? It is not. Then is it greater than 29? Of course it is greater than 29. Okay, current value 30 is greater than 29, right? Then again we don't need to check all the other column values, because if the smallest element is greater than the 29, all the column values have the greater values than the 29, because all the columns and rows are sorted. Okay, now again we move to the left. Okay, if this condition occurs, we will go to the left for the minimum value. Now we came to 20. Okay, we'll again traverse there. Now we will again compare, is 29 is equal to 20? That is not, false. Then we will check, is the current element, that is 20, is greater than 29? Okay, that is not. So there is a third condition as well. Okay, if C is smaller than key, okay, that is the smaller element, we will get a smaller element. So if current is smaller than the key, it means we do not require or need to iterate over its left element. Okay, and why this is happening? If 20 is the first smallest element that we hit, okay, so its all left values are smaller than the key. If 20 is smaller, then its all left values are also smaller, because the row is also sorted. Okay, so the particular value's left value contains the smaller element than the current value, and because this is the first element in this row while traversing from the right is the smaller element than the 29, it means it is the closest smallest element of 29. So we do not require to check the other rows values, only row values, we can check the column values. Okay, it means if we hit an element which is smaller than the key value, so we require a maximum value than the current value so that we can reach to 29. Okay, now to get a maximum number, we will go to the downward direction. Okay, so now we will go from 20 to the 30. Okay, so if the current element is smaller than the key, okay, we will go to the downward direction. Okay, now again we compare 30 is equal to 29 or not. Okay, that is not, false. Then again we will go to the second condition, is current value is greater than key? That is true. Okay, true. So we will not traverse these also, because if the 30 is greater than the current element, then its all downward values will always be greater than 29, due to the sorting. Now if this condition occurs, we will go to the left. So we will go to the left. Okay, now again comparing, this 29 is equal to 29, that is true. So we will have the true condition on the first condition. Okay, we will return the particular row, that is 1, and the particular column, that is 0, simply. Okay, we can return as a string or in particular array, this doesn't matter. The thing matter is how we are iterating. Okay, let's suppose there is no 29 here. Okay, suppose it is 28. Fine. Now in this condition 28 is smaller, right? Now because 28 is smaller than the 29, so in the smaller condition we move to the downward direction. Okay, we move to the downward direction. Then 30, we came to 30 is now greater, okay, than 29. Then we do not need to check these conditions, okay, we will go to the left because this condition will get true. 30 is greater than 29. So left direction like this. Now when we decrease the column value by 1 when we are in 0, then we go to -1. And when the column hits the -1, it means the iteration has been ended. There is no any further column. If we hit C is equal to -1. Okay. Similarly, in the rows also, if we traverse and goes to the row is equal to 4, so there is no any fourth index of that particular row. Okay. So if row reaches to n, okay, there is no any index of n, or if the C reaches to -1, so either the condition true, this or this, we will stop iterating. Okay, it means we are not able to find the 29. Okay, so this is our base condition. Now coming to the question that why it is called staircase, because if you carefully see, the iteration is like a staircase. Okay, at first we go 40, okay, fit 30, fit 20, then 30, then 28, then 30, then this. So it's like a stair, therefore it is called staircase search technique. Okay, and in this we will have the time complexity is 2n. Okay, 2n. Why 2n? Because in the worst case, if we count, in the worst case we will traverse from here to here. Okay, so we will go to this much of length, that is 4, and to moving downward we will have the downward 4 or 3. So it is similar to 2n, and during the time complexity we will ignore the constants, so it is equal to of n, or linear time complexity. Okay, now jump to the coding compiler. Now we came to the coding compiler. Let's make a file solution.java, solution11.java. Okay, now having a main method. Okay, now at first we are going to take all the inputs. Okay, so before taking it, we will import the class scanner, and as all the inputs have the same data type, that is integer, so we are going to use the next int method of the scanner class. So before using it, let's make the object of the scanner. Okay, now taking the length of the array, now making an 2D array. I'm calling it mat, and these are of size n cross n. Okay, now taking all the input of that particular index, I is for row and j is for column. Okay, like this. Now we have to also take an input of search key, that is key. Okay, to solve this problem I am going to use a dedicated method. Okay, you can also solve here, but I recommend, if the program is a little complex or a lengthy, then you should make a dedicated method to solve the problem. Okay, so static, and I am returning the string from here. Let's say key, the length of the array, and the array. Okay, what we are going to do first is we will at first take the initial position of iteration. So in row, we are going from the 0th, that is the first row, okay, and the last column. So column will be n minus 1 is the last column, okay. Now I am saying while till when the iteration occurs when c is greater than minus 1 and r is less than n, okay. These are our edge cases. While c is greater than minus 1, which means we are not ended from the column side, and end, okay, as well as r is less than n, it means we are not ended the column wise as well. So we can iterate if this condition fulfills. Now what we are checking in the first condition, we checked if the current element is mat of r and c is equal to our key. If this happens, okay, if this happens, we'll simply return a string. I am using the string.format. You can use the plus plus or something like this format, which is found at %d for the decimal value and %d for again the decimal value. On the first decimal value, I am placing the row and column. So you can also use found at, then plus, then value r, plus, then comma, then again plus. So instead of this, I am using the string.format method. In this, we have to pass a string with a particular placeholders, okay, and according to the sequence of this placeholder, we have to pass the arguments as well, okay. So on the runtime, these placeholders will be replaced by their arguments, respective arguments, that is replaced by the first, and second d is replaced by the second, okay. Now else, if it is not equal, then again there is two condition, okay. If mat of r and c is greater than the key. So what we were doing, if our current value is greater than the key, we will go to the left, okay. It means if we are moving to the left, our row will be the remain same, okay, row will be the remain same, but the column will decrease by 1. So column will decrease by 1. Else, and what is in the else condition? It means smaller value. The current value is smaller than the key, as it is neither equal nor greater, then it is smaller, okay. So if it is a smaller value, okay, the current value is smaller than the key, then we will go to the downward direction. And how do we go to the downward? In the same column, we will not change the column, we will only increase the row, okay. So we will simply increase the row without changing any column, and to going the leftward, we will simply decrease the column while the row will remain same, okay. So this is what we have to do. And after the iteration, if this condition doesn't hit any one time, okay, then the return will not call anytime. And if return will not call, it means we do not get the particular key, or the particular key is not present on that particular matrix. So we'll simply return no, or sorry, element not found. Okay, please check what we have to return on this and this during your NQT, because this is case sensitive, okay. So case will matter, and we cannot, if it require this not, then we cannot do this not, okay. So this will print according to the requirement. The problem statement will mention what you have to print when no element is found, or if you found any element, okay. Now if this method return a string, okay, of this, so we don't do anything, we'll simply print the returned value. We'll passing the key, the n, the length of the array, and the particular matrix, okay. Now let's check by running it. Okay, we are giving the values, okay, let's Now we are giving these values according to the question. Okay, 4, there is 4 by 4, then 16 values, then the searching element is 29 and 29 is present here. Let's enter and we can see found at 1 comma 0. Okay, here, and let's again check. Okay, and I am trying to find 28. Okay, element not found. Okay, the code is working pretty fine. Okay, so that's all for this video. If you have any type of doubt, you can ask in the comment section, and whenever I got your comment, I'll reply for sure. So meet you in the next video with a new problem. Till then, keep learning and happy coding. Thank you.